Hello everyone, and welcome to this NNUJ meetup. My name is Oddrun Bakke, and I will be your host for tonight, together with Henrik Walkemo and with Håkon working behind the scenes. For the ones that are new to the group, welcome. And here's a little intro about us. We are part of the .NET Foundation, and we are an independent user group with focus on .NET. That is, by developers, for developers. We are also always interested in people that have something interesting to present, and we tend to focus on talks with subjects based on practical experience. So if you have something or know someone that might have something interesting to talk about, please contact us by mail, Twitter, or by any other platform. We would also like to thank our sponsor. Without them, this would not be possible. The NNUG board consists of these people. These are the ones that organize these meetups. We also have a short survey right now, and as you can see, there is just 6 short questions that shouldn't take too long to answer. We would really appreciate it if you take the time to answer them, and if you have not done some already. Yeah. We also have an Energy GitHub challenge right now, where you can complete a set of modules on Microsoft Learn. This is a competition that will start tonight at 1800, and it ends on Monday, 800. Of the ones that completed the most of the modules, there will be a winner that will get a Microsoft backpack. Also, of the ones asking the best technical questions during the talk, we will draw a winner of a Microsoft backpack. You can also get a digital badge by visiting the link on the screen. Today, we are so lucky to have Bas Peters here to talk about code to the cloud with GitHub. The presentation will start soon, and there will be a Q&A session afterwards. Please also ask questions during the talk for the Q&A. So with that, I give the word over to Bas.
Thank you so much, and thanks for having me at the meetup here. So let me just share my screen. Give me 1 sec here. So can you all see my screen? Can someone confirm? All good? So yeah, thanks for having me. My name is Bas. I'm a solutions engineer with GitHub. Solutions engineers at GitHub are more like technical people. We are part of the sales department, and it is our goal to help customers to adopt the GitHub platform. I'm based out of Amsterdam. So I joined GitHub more than 5 years ago in 2015 when GitHub started building a presence in Europe. So before that, most customers of GitHub based in Europe, they were served from our main offices in San Francisco.
Sorry, Bas, it seems
please.
like the screen sharing wasn't working. So maybe
it was not?
try that. Yes, it wasn't working.
Okay, thanks. Let me just go back. So you cannot see my screen at all right now?
Oh, now, okay, let me add it to the stream.
Is it working now?
Yeah, now it works.
Yeah? Also, when I move to slides?
Yes, it works. I'm moving slides too.
Thanks. Okay. Yeah. I asked confirmation before. I didn't hear anything, so I thought it was fine. So I apologize for that. So I will just continue. So Bas, solutions engineer at GitHub, based out of Amsterdam. I work mostly for customers that are based in the Nordics. So, before the whole COVID crisis, I spent a lot of time and I would normally have been in front of you on a stage presenting, but that's not possible right now. So for those who are less familiar with the GitHub platform, so GitHub is a large developer community. There's like 56 million users of the GitHub platform. There's lots of projects there. As most of you are .NET developers, to some extent, I guess you are familiar with GitHub because a lot of the tools that you're using, and of course also the language itself, so at least .NET Core, is maintained on the GitHub platform. And so Microsoft, for years, they've been the largest organization in open source on GitHub. So apart from .NET, there's a lot of Azure cloud tooling, for example, maintained on the GitHub platform. And of course, there's also the editor that I think many of you will use, Visual Studio Code, that is maintained. And that is really a great example, I think, of an open source project maintained on the GitHub platform, because they managed in 3 years' time to become like the most used editor. And that is thanks to it being open source, because anyone can contribute. So people provide bug fixes, but also, that they managed to build a community that, for example, builds plugins, and so helped to broaden the scope of what you could do with Visual Studio Code. So I think it's one of my favorite examples, I think, of the power of open source. Now, GitHub has, apart from the most open source projects are maintained on the GitHub platform, there's also a lot of DevOps tools maintained on GitHub. And then, of course, we have a lot of customers. Traditionally, there were a lot of innovative companies that were using GitHub, like Spotify, for example, or Slack, or Netflix. And these were companies that, Netflix, I think, is a great example here, that not only were building software internally, but also open sourced a lot of the tools they were building. If you take Netflix as an example, I mean, their competitive advantage is not with the software they write, it's about the distribution rights. They produce like Hollywood nowadays. So that is their competitive advantage, and not really the tools they build. So a lot of the tools are open sourced. And that is also a great way to sort of, to build a presence in open source and then attract developers. They can see what stuff you're building, and that is a great way to, to attract them into your company. So GitHub is deeply rooted into the open source community. We want it to be a home for all the developers, and then also it is a home today for most open source projects. At the same time, on the other end, when we talk about deploys, then GitHub is an open system, so you can deploy to any platform. It's not bound to any specific cloud provider or anything. It also allows you to integrate with many different tools. So it's a very flexible platform to use for software development. If you look at the focus, and I will just discuss some of these in this talk, then you can see that our focus nowadays is on security. That is a really important part, and I will discuss this in a bit more detail. Then, of course, code to cloud. There's more and more customers, implementing workflows for continuous deploys and things like that. Of course, collaboration is a really important part. A lot of our customers use GitHub because it's a platform that allows you to collaborate on software development, and not only within your team, but also across teams, or even together with the open source community. And finally, it's also a platform that is great for developer talent. Also for you as a developer, a lot of developers, they maintain their profile on GitHub, similar to how you might have a LinkedIn profile. The GitHub profile is like your developer profile, where you can show, showcase some of your open source projects or contributions you've made, but also tell a bit more about yourself. Nowadays, you can even include a README file into your profile, so you can really kind of provide additional information about your developer profile. And underneath this really is the community. I think even when we build our products, we think about how can we leverage the community. So how can we allow the community to sort of also be part of the development of these solutions. We do that for security. We do it for GitHub Actions, for example, but I'll talk a bit more about that later. So before we dive into security, I want to very quickly walk you through the typical GitHub workflow. So GitHub invented the pull request workflow that you will, I think most of you will use Azure DevOps today. And in Azure DevOps, you also have a pull request that you can use in order to sort of propose code changes to your team. And so that pull request workflow is really what is, you could say, like, was the biggest innovation that GitHub brought into the developer space. It was a way of allowing developers to build software in a collaborative way and to request peer review, whether in an open source context. That's why it was designed, to provide an open source workflow that was not there when GitHub was founded, but also within your team itself. We are also continuously sort of investing in this workflow. Typically, it's based, of course, on the Git version control system that I think most of you will be using. And it starts by just creating a branch, making some commits, and then pushing the commits to the server, and then opening a pull request to share with others, share with your peers what you're working on. On GitHub, you can open a draft pull request. I think you can also have support for that in Azure DevOps. And a draft pull request is really kind of, showing your peers that it's work in progress. Don't judge me by the code I'm writing because I'm still working on it. And then you can open it up for review. So on GitHub, you would typically click ready for review, and then you can invite people, or there's also, we use some kind of algorithms underneath that also can automatically sort of suggest the right people to review your code. One of the things we're working on in terms of code review is provide better revisions and kind of better cycles. Now it's, now typically a review is done and then the comments are, fed back into the developer. You can do suggested code changes that can immediately be committed by the developer, but there's not really kind of a way of sort of pausing a review cycle, which is something that we are working on, and that will make the workflow more transparent especially to reviewers. Where as a developer, you can say, okay, I'm working on the suggestions right now, so I will pause review, make some changes, and then I will open up for another review cycle. And then finally, there is, of course, also a validate step, and that is something I will briefly explain how we, for example, deploy at GitHub, because the way we deploy is somewhat different than what most organizations would do. In most cases, when you use the pull request workflow, you might merge it into either the main branch, or maybe there's a staging branch that you will have. So if you use more like a Git flow where you have multiple long living branches. But the way we deploy at GitHub is we deploy from a feature branch. So if we go back to that workflow and we see there the line underneath, so that feature branch that is split up from the main branch, we deploy from a feature branch into production. Nowadays, we have kind of a merge queue, so you can join a queue, so multiple features can be shipped in a feature branch at the same time. And then we first deploy to Canary in like 2%, then we increase the percentage. And if we do not see, so, developers would typically jump into monitoring tools and start looking into, okay, what is the behavior of these changes in a production context? And so they will check whether is there an increase in exceptions, for example, or a decrease in performance. Then there's always a way of sort of, rolling back and making further changes. And then when they deploy to the 20% Canary is fine, they will deploy to production, continue monitoring, and only after it's successfully deployed into production, they merge the change set into the main branch. And this way we have a very simple workflow that guarantees that we always have a stable main branch, so we can always roll back if something goes wrong in any of these steps. So I just wanted to quickly sort of, share this with you as an alternative way of deploying changes. The merge queue capability that we've quite recently built, and I hope this is, this will become part of our feature set in the near future. Because I think it's something that a lot of our customers have requested, being able to sort of queue a bunch of changes in order to ship them into production in an easy way, and also, providing rollback capabilities so you can opt out, at the last minute if needed, if you discover some last minute errors in your source code. Then finally, on workflow, what I want to share is a few things that are, considered best practices. What we always sort of share is like open a pull request as early as possible. So we still see a lot of customers where developers open a pull request when they think their work is already done. So it's really late. And then it's often a bit too late for receiving feedback. So now the earlier you open your pull request, and you can open it as a draft to make sure that people don't judge you by your code, then you can receive early feedback. So you can also make changes very early in the process, and that can save you a lot of time later. I mean, imagine working a week on some capability, and then some peer comes, provides us feedback that, oh, if you would just bring in that particular third-party library, then there's no need to write all this code. That will be a waste of time, and it's not very motivating. The other thing I just want to mention, I'm not going through this whole list, is really kind of, if you open a pull requests, you don't have to merge a pull request. So you can just use pull requests also in a great way to just do experimentation. Just like on Git, you can just create a new branch, and start experimenting. And if your experiment fails, you just throw away that particular branch. So I think that is also something that developers should do more often, is just using pull requests just to do experimentation. And you can always communicate in the description of a pull request, like, what is the purpose? I just want to do this particular experiment. I don't know, if it will ever be successful, but I just want to see if this particular change is going to help us improve our product, for example. Then, of course, there's templates, and automation is important. GitHub also has branch protection, like you also have in Azure DevOps. So you can secure your workflow in many ways, like making, for example, adding required reviews, required statuses, and things like that, in order to harden your workflow and make sure that bad code is never merged into your main branch. So if we look at software, building software today, and that is definitely the case for you as .NET developers, is you consume, the language you will use is in a huge part open source, and you will consume a lot of open source libraries. And that is, how we build software today. We build on top of open source foundations. We're not going to write all this boilerplate code ourselves. But that also has impact, of course. And that is something that we've been investing heavily in at GitHub over the last few years. And that is providing a secure workflow on GitHub to help you to secure how you consume third-party libraries. And so that starts by providing tools to security researchers, and also building a community of security researchers to help them, so they can identify vulnerabilities in open source libraries, and providing them a secure way of disclosing those vulnerabilities on GitHub, and then allowing maintainers to create a private fork, so not exposing that particular vulnerability, and help, allowing them to create a fix. So GitHub is also like a CVE numbering authority. So a maintainer who is working on a fix for a vulnerability, they can, in the advisory that they create on GitHub, so that is like a form where you provide details as a security researcher or developer, like reporting a vulnerability, maintainers can also request a CVE identifier from GitHub. And before we did that, what we saw is a lot of open source maintainers, they would definitely fix vulnerabilities, but they would never, or not very often, request a CVE identifier. And if you do not attach a CVE identifier to your vulnerability fix, then it will never appear in any of the kind of vulnerability databases. And as a result, you as a developer will not be notified. You will not know about it. So, the only way then to fix these things is just making sure that you keep the libraries up to date, because you don't know if there is a vulnerability, unless, of course, you start digging into the code changes for every release. So by becoming a CVE numbering authority, we managed to increase the number of maintainers that do request a CVE for their vulnerabilities. And then, of course, we also maintain as GitHub our own advisory database. So a database where we import CVEs from external systems, from developer communities like NPM, for example, or PHP, the National Vulnerability Database we bring in. And then there is all the advisories that are reported on GitHub and fixed on GitHub that also end up in that advisory. And then based on that information, we can alert you when there is a known vulnerability in any of your third-party libraries that you consume. And then on top of that, some of you might be familiar with the capabilities. We have a bot called Dependabot, and Dependabot can help you to sort of to support you in making it easier to fix those vulnerabilities. I will show you a bit later in a brief demo. And the whole idea of this process is what we want to achieve is sort of bring security into the pull request workflow. So bring it into that GitHub flow. So whenever you make code changes in a pull request, report any vulnerabilities right there in the pull request, rather than very late in the software development process. Maybe, sometimes what we see is customers that only start looking into any security issues during acceptance tests, for example. But you as a developer might already be working on other stuff. So you really need to kind of context switching if someone reports an issue, like, what code was it? I wrote that 2 weeks ago. I totally forgot about it. And then you need to sort of, switch context and start fixing things. So the earlier, you can fix stuff, while you're working on those code changes, the less friction there is in your workflow. If you look at the capabilities, then on GitHub, we provide built-in security alerts using the basics is a dependency graph. So we build like a graph that provides you a graphical overview of the dependencies you're consuming in your projects. And then we will alert you when there's known vulnerabilities in any of those third-party libraries. And then we can also automatically open a pull request with a suggested fix. If that is so, to help you to make it easier to remediate these vulnerabilities. On top of it, one recent feature that we've added to this is also like when you add a third-party library as part of, so let's say in your NuGet file, for example, your manifest, if you add a third-party library and as part of a change set in a pull request, and it introduces a library with vulnerabilities, we will also annotate the pull request. So we will show you in the code changes that there is something that you need to fix with that third-party library. So maybe bump it to a newer version, for example. And we also support dependency updates. So for things like Docker images or your Terraform modules, or of course also your .NET dependencies, but also a third-party GitHub Actions, so the workflow steps, you can allow Dependabot also to help you to keep things up to date. So whenever there's new releases, it can open a pull request for you if you want. This is purely optional in order to suggest an update and to quickly sort of merge that change in order to update your third-party libraries that you're using, or container images, or third-party actions, or Terraform modules. And then, so now I've been mostly talking about like third-party libraries, so like dependencies. GitHub also provides code scanning. So a company called Saml joined GitHub last year. They have a technology that is a code scanning SaaS solution based on a query language. And so what they do is they can create a snapshot of your source code. So at some point in time, so on some commit, they can create a snapshot. And then you can run a query pack against that snapshot with queries that are codified vulnerabilities. So like SQL injections or other OWASP-related vulnerabilities or other vulnerabilities. And these are also integrated into the pull request workflow. And then security researchers also can use that query language called CodeQL in order to write their own queries. And these queries are all open source. So there is a CodeQL repository in the GitHub organization on GitHub that contains, for all the supported programming languages, all those queries. So you can also learn from it if you want to learn to write CodeQL yourself or adapt these queries. And then a lot of customers that use this code scanning solution, including Microsoft, for example, but also Google and Uber and a lot of others, they have security researchers on the payroll. And so whenever someone reports security vulnerabilities through a bug bounty, for example, those researchers will codify them using CodeQL and contribute them back to the CodeQL repository. So they can be included in the query sets that you can run against your code. The code scanning capabilities are completely free for open source. So you can give it a try if you have some open source and public repositories, for example, or you're contributing to open source, then you could add code scanning to give it a try. And then, so the next part I want to talk about, and then I'll go through a quick demo, is like the deploy, so GitHub Actions. I think one of the things a lot of our customers are working on is like, you could say ship more often, right? So GitHub itself, if we look at github.com, for example, we use a continuous deployment model with github.com. So we deploy multiple times every day. You can see on the GitHub blog page, or blog.github.com, there's a change log where you can see what we ship. So for every feature that we ship, we write a small piece of, a small kind of release note, you could say, for that particular feature. Then there's also GitHub Server, where we have more a distributed model, and we cannot sort of send like an update to our customers like every day. If I like upgrade your server, so that is, of course, that has a complete different cadence, where we have like kind of a quarterly feature major release, and then in between those major releases, we might have just batch releases. So I think most of you are familiar with Azure pipelines, so I will compare a little bit with Azure pipelines. So the backend of GitHub Actions is actually is based on, you could say, like a fork or a copy of the Azure Pipelines backend. So when Microsoft acquired GitHub, then one of the first teams to join GitHub was the Azure Pipelines team. So they joined GitHub to continue work, of course, on Azure Pipelines, because that's not going away. But they also helped the team at GitHub to build out GitHub Actions. And there's a few differences. In GitHub Actions is very community driven. So on the marketplace, there are thousands of actions written by third-party vendors that you can use. So it's very much based on an open source ecosystem. And so, for example, the Azure Cloud team have written a lot of actions that you can bring into your workflows to deploy to Azure, whether it's like, you know, Kubernetes or, you know, functions, or to databases and things like that. We do support any operating system like Azure Pipelines does, because we're sharing the same kind of backend. And you can run GitHub hosted, or you can spin up your own agents. And we're also working on a new capability where we have like premium runners, as we call them right now, where you have more options in like deciding what kind of size of machine you want to use to run your workflows. GitHub also supports packages, so you can use, like you have artifacts on Azure DevOps. We also provide packages and a container registry. So I'll just skip this slide, but these are some examples of the GitHub Actions that you can use for Azure. So written by and maintained by the Azure Cloud team. But there's also, if you use Terraform, for example, HashiCorp have written actions that makes it super easy to sort of apply Terraform modules, or there's actions for Ansible, for example, and many other vendor tools that you can use in your workflows. One very neat thing also that I find about GitHub Actions, I think if you're super familiar with PowerShell, for example, I think you can very easily write a lot of like custom stuff using Azure Pipelines. And then, of course, there's also a plugin ecosystem, where with GitHub, it's I think it's a very simple to extend. So to write your own actions, you can use any language. So you can containerize steps in your workflows quite easily, or you can use JavaScript or TypeScript to write. But there's also, this is one of my favorites, there's an action called GitHub script that allows you to sort of write arbitrary kind of logic. So it's mostly used when you want to interact with the GitHub API, and you can just use JavaScript right into this action, or even reference a file, so you can nicely write a separate TypeScript or JavaScript file with logic. So you can easily then extend your workflows and do custom stuff without having to really write an action itself that needs a metadata file and things like that. But even writing actions is quite simple to do on GitHub and very flexible. So it's highly customizable. And what we see is some customers that use Azure DevOps today, they're interested in adopting GitHub Actions for that reason, because they might have very custom workflows. Like I've been working with a customer that builds sensors, for example, and they have very specific sort of hardware testing that they do. And there it's very easy to just write scripts that will support these custom workflows without having to spend a lot of time in writing plugins or to support this. There is also still a few gaps between pipelines and GitHub Actions. So we do have workflow visualizations now, so that is a good step, because until recently we did not have those, like you have in release pipelines, right, in Azure pipelines. So the visualizations we have now, we also have manual approvals, but there's also some things that we're still working on. For example, having more policies in your release pipeline, so more automated policies. So there is a manual approval right now, but if you want to if you have policies, for example, conditions to go from a staging to production that go beyond a manual approval, then that is still something that we are working on. So I think their release pipelines with Azure pipelines is maybe more mature today, but the team is working to fix that. Packages I mentioned, so that is, it supports the different ecosystems, including NuGet, of course. We also have container registry. So of course you have container registry also in Azure, so you might use that today. On GitHub, we also have a container registry that is on a higher level. So it's not on a repository level, but on an organization level. So that allows you to store images and then also, control fine-grained access, for example. So what projects have access to these particular container images. Or you could even use anonymous access. So you can have public container images on GitHub that you can share anonymously. So anyone could fetch those from GitHub. So I want to show you a few things on GitHub. I think it always helps to just do a brief demo. So I hope that my screen sharing is still fine so that you can see my screen here, my browser. So we're looking here at the project. So I do need to apologize here because, I mean, if we look at the languages that are used in this demo, we see Java primarily. So this is a Java project rather than .NET, simply because I just wanted to show you a few security related features that are, I didn't have like an up-to-date good .NET example. So we do have a .NET version of this particular demo. It's a very simple web application that lists books. So there is a .NET version, but I do not have an interesting case where I can show you some of the security features. So we talked about security features in a sense, like there's like security features related to your dependencies. So there is a dependency graph that is enabled here, the dependable alerts, then the security updates, and then there's the advanced security features around code scanning. And I didn't talk about that much so far, but there's also secret scanning on GitHub. If you work on public projects on GitHub, secret scanning is enabled by default. You cannot even turn it off. So if you would leak a Terraform token or maybe an Azure cloud token or an AWS cloud token, then we would immediately revoke that token. So that is a workflow that our partners, so partners like the cloud vendors, for example, or HashiCorp implement together with us in order to help you to keep your code secure. We don't want you to get into a situation where you leak some cloud token and then someone just takes that key and starts, mining Bitcoins, for example, on your bill. And so if we look at insights, then on GitHub, so on your project, you will have the dependency graph, and the dependency graph will show you like, what libraries am I using? So these are the third-party libraries that the project is consuming. So there's about 16 in this small Java project. Also, I think in .NET, you would typically have, a decent amount. If you look at JavaScript, for example, there you would easily, with even the smallest application, you would already end up with hundreds of dependencies. So then the dependency graph is pretty handy. Then we see the banner here. So there is a vulnerability in the JUnit dependency that we have. And I can just from here, and here we see the connection also between your projects and the GitHub platform, because this project is maintained on GitHub. So I could immediately jump into that project from here. So we try to really bring that open source community closer to you. So if you want to learn more about that project or what's going on, dig into like the pull request, for example, related to the security issue, you could easily do so. What I would typically do to remediate, I can either go to the security tab. So this is the page where we're bringing all the security related features together. So we can also see here the security advisory. So that is like if someone would want to report a vulnerability to this project. And then we see here the dependable alert, and we can jump into the details here. On top, we already see that there's a pull request associated to this. And we also can find more information. So we bring this information from the advisory database into your project. So you can learn more about this particular vulnerability right from your project. So there's no need to sort of switch context, go to some other system. It's all in GitHub. And then there is this pull request. So what I've done here is I've configured a dependabot bot. And so the bot created a pull request for me with a suggested fix. Now, there's a few interesting things here. There's a few benefits here. So one is because there's so much source code maintained on the GitHub platform, there we can calculate a compatibility score, just looking at all the projects on GitHub that have this particular issue. And then we can calculate how likely is it that there are breaking changes when I apply this fix. The score is 97, so it's not very likely. So I'm pretty green here. So to me as a developer, that helps, just, doing sort of a quick impact analysis and like, okay, what is the impact of this change on my source code? And then, of course, because Dependabot already opens the pull request for me, I have my also the results from continuous integration server. So I can see all my build statuses are green. So that also helps. So the only thing I have to do now is, just go into the files changed and just check. You can see that the change is really simple, right? It's just a version bump, and in NuGet it will be no different. So it's a very simple fix, but just by bringing this information together, I can very quickly sort of judge, and you can even allow automatic merges. So you could sort of approve this and then let these things be automatically merged into the main branch in order to fix this particular vulnerability. So this is a vulnerability related to a dependency. And there's a bunch more here. You can see these are all opened by the bot. So the ones that have the blue label here are all, there's also one for a GitHub action. So an example for a third-party action that I use in my workflows that is not up to date. So this PUR, when I would merge this one, it would update also my workflow pipeline to reflect the newer version. But the one that I want to look into is this pull request here. And there's a few things here. So one thing is that we do see, if we scroll down, so we see here a red cross here. So the code scanning reported issues. So when I go to the details here, in my pull request, I can, this is like you have on Azure Pipelines, right? Like the build summary page. And on this page, I can see here that code scanning found 2 issues with my source code. So there is a query built from user-controlled sources. So that is like a SQL injection. And then I'm using a cookie. So I'm declaring a cookie somewhere in the servlet class. And that is not done in a secure way. So I can also go into the files changed, which is typically the page where you would do code review. And when I scroll down here, I will also see those annotations in the context of my source code. So this helps me also as a developer to understand, okay, where are the issues in my source code? So they're related to this line here, because I'm executing a query here. And in that query, I just concatenate input from the user. To understand it better, I can click Show Paths, and this provides me with an overview from source to sink. So where does the information come from? In this case, user inputs that I read from the user interface, and I create a search string here, and I pass that string to the controller. And then in the controller, I just concatenate it into a query. So potentially, the end user could just write part of a query here, and it might work. They might, I might expose information I do not want to expose to the user, or the user could even kind of write an update query maybe and just corrupt my data, which is not something I would want. So this is a neat way of sort of understanding, how does the data flow through my classes in order to better understand the vulnerability you're working on. In some cases, as a developer, this might be sufficient. You will immediately understand, I should have used the prepared statement here. In other cases, you might not be familiar. So you might still wonder, how am I supposed to fix this thing? So then you can just click Show More Details. And this will bring us back into that security page where we bring everything security related together. And this is where I can just read more about this particular vulnerability. So this is an article that we provide right into your repository to learn more about it. And the goal here is to, as a developer, to give you sufficient information to fix it. So we provide context, so you will understand the vulnerability. And then we also provide examples on, how can you remediate this? How can you fix this? So we have like bad examples. You can see here the concatenation again. And some good examples is like, using a prepared statement. And if you're unfamiliar with prepared statements, we also provide links, so to for reference about the vulnerability, but also, for example, to documentation where you can learn more. So if you're, as a developer, not familiar with prepared statements, you can just jump to the tutorial, learn more about them, and then go back to your source code and fix it. So the whole idea here is that shift left. Is like, when you are working on those code changes, provide you with sufficient context to help you to keep your code secure, and do that right into, right at the moment when you're still writing those code changes, and not at the end of the whole developer life cycle. I want to show you a few other things on that pull request. So more related also to the support for code to clouds, like deploying. So one of the things here, if I go back to let me scroll down here a bit. We can see here that there is a successful deployment. So GitHub provides environments. So if you have the capability to define environments. So what we have here is a deployment to our test environment. So this is what is currently in production. So this list, and I haven't tried before the session, but let me just launch this one. I don't know how fast it will be. Yeah. So you can see here that I have my, these are the changes I'm working on. So this is currently in production, and here you see the rating. So this pull request is about adding a rating feature to my bookstore. And so I can have different deploys to different environments. And when I go back to my code here, then on the right-hand side, I can also see that I have these environments. I have the test environments, and I have the product environment. And I can also jump into those environments and see the activity log. So this is, providing more context related to the deploys I'm doing. Apart from this, of course, GitHub has support for, of course, Git tagging, but you can create releases on GitHub. So typically, if you will release a new production release, you would create a release on GitHub. I do not have an example in this project here, but that is something that is, of course, also related to your environment. So when you ship to production, create a release on GitHub and add the release notes there, either in an automated fashion or by hand. And this, of course, provides you with end-to-end traceability all the way back to the planning and tracking the work items, for example. If you're using pipelines, and maybe if you want to explore GitHub or want to use it for software development, and you've invested heavily in Azure pipelines, you can also perfectly use Azure pipelines with GitHub. It provides a seamless integrated experience. So it will also use this summary page on GitHub, and that will have a link that brings you straight into your build summary page on Azure DevOps. And then the other part is that I think there's definitely a feature gap between Azure boards and planning and tracking on GitHub. GitHub is pretty lightweight in its project management capabilities. So I think that is an important part where we do see customers moving their code to GitHub, for example, to build a more collaborative software environment, like building an internal community or using the security features. But at the same time, using Azure boards for planning and tracking, because we're working on it, but it will take a while before we will have feature parity there. So I think that is important to note. So there's definitely still some gaps between Azure DevOps and GitHub, and also, of course, the other way around. So I'll just go back to the presentation now. I hope that it will render fine for you. So there's a few other things that I just want to mention. So I'll use the last 5 minutes for that. On GitHub, you can also host documentation. So you can host your websites on GitHub, and which is a great way. It can be like software-related documentation, or there are so many websites around that are hosted on the GitHub platform. A lot of open source projects have their own. If you're digging through the Microsoft docs a lot, then most of the Microsoft software related documentation, where there's for Azure Cloud, for example, is all maintained on GitHub and is published from GitHub repositories using GitHub Pages technology. And these are public. And for, until recently, GitHub pages were always public. There was no way to sort of restrict access, which is now finally shipped. I think last week we shipped this. Now what you can do, you can say, I want to host a website on GitHub, but I only want to give my colleagues access. So my team, for example, or, the whole community internal to an organization. And I think, I've been waiting for a long time for this feature to ship. But it's a really great way of sort of, hosting documentation on GitHub right where your code lives. You can use the GitHub pull request workflow also to sort of work on changes. So, even if you have documentation, people that just consume those documents, they could very easily sort of contribute fixes for your documentation, because they will always know, where the latest version is maintained on GitHub in a repo. And they can even just, propose through a pull request, they can even propose updates to the team. So when they come across something that is not up to date, they can just contribute. And this can help you to keep your documentation up to date easily. I also want to briefly mention a few clients that we provide as GitHub. So there's GitHub Desktop, which is a kind of a desktop providing a lot of support for working with repositories or creating branches, checking out them, pushing changes. So if you're not really a command line person, then GitHub Desktop can be a great alternative to interact with a GitHub environment. We also provide a GitHub CLI, so a command line interface that you can use. So if you love command line interfaces, you can do the whole pull request workflow just by using the command line interface. But of course, and you can even run API calls against it, and then you can create aliases. So if there's API calls that you use a lot, maybe because you have some administrative tasks on GitHub, that is something you can perfectly do, and you can just create an alias so you can store those calls for later reference. Similar to how you can do with Git, right? On the Git client, you can also write aliases for, combining Git commands, for example, like having nice reporting capabilities or something else. Of course, Visual Studio Code. My guess is that quite a few of you are using Visual Studio Code. It fully supports the whole GitHub workflow from end to end. So you can even do code review right from Visual Studio Code. So if you live inside Visual Studio Code, there's no reason to just leave it. You can just view what pull requests are open, or have people requested my review, and then you can just jump into the diff view and just add commands, suggest changes to your peers. This is all supported from within Visual Studio Code, so you can just from end to end. And that's of course the same thing for if you use Visual Studio, that provides the same level of integration with GitHub. This is a neat tool if you want to use APIs a lot with GitHub. Using Insomnia can greatly help you, because we provide schemes that you can just load into Insomnia with the API endpoint, so that could be helpful. One other technology that we have currently in beta, and hopefully we will, I think close to summer, it will be general available, which is code spaces. This allows you to sort of define virtual development environments. So either you can run them through the browser using a browser-based version of Visual Studio Code, or you can use, there is a lightweight Visual Studio version, for example, that allows you to sort of, it's like a skeleton that will run the code space from within your Visual Studio. So it doesn't need a lot of resources from your local machine. It's super lightweight, because the hard work is all done in the code space that lives in the cloud. And so you can define just once. So you can define a code space once. So for a project that requires a lot of configuration, you can define it once, and then you can distribute it to teams. This is especially neat if you have a lot of contractors, for example. So a lot of kind of people that are outside collaborators that you are contracting for a few months. They do not waste their time, trying to sort of set up, the whole development environment on their local machines, and maybe you don't even want to do that from a compliance point of view and security point of view. So you can just provide them with a code space where they can contribute, like within, I don't know, minutes, you could say. The only thing they have to do is spin it up once, and then they can start working together with your team. There's also a few APIs that I want to mention related to sort of automating things around, also, especially around continuous deploys or doing deployments. We saw the deployments API is to build those environments that we saw in the demo quickly. Of course, there's releases you can create. The checks page, so the summary page that we saw, you can also program against it. So you can write your own custom checks if you want to. So if they will be reported into that build summary page that we saw a few times where those annotations were. And then the statuses are the statuses that you saw that list in the pull request of build statuses. And you can also quite easily, you can see one in the bottom here, that's the Azure Pipelines build status from the .NET project I mentioned at the start. But you can also add your own statuses. So if you have your own sort of custom steps in your pipelines and you want to report them as separate statuses, so with a separate, their own outcome, you could say, whether green or red, you can also use the status API. Then finally, these are really my last slides, and then we will open up for questions. So if you go to docs.github.com, there you can find all the documentation. It's neatly sort of ordered by topic, so github.com, but also for our clients or APIs. It provides information. So this is where you can find a lot of examples. We also have the blogs.github.com. And then there's also a lot of learning resources that we do provide. Also on Microsoft Learn, there's a lot of GitHub related courses that you can just follow along through Microsoft Learn, or you can go to lab.github.com where we have a bot assisted courses that you can also follow. So there's also plenty of learning resources to better understand particular GitHub features. And of course, on the blog.github.com, we also post frequently whenever we ship new things, we will blog about it there. So it's a great way also to keep up to date with what we're working on at GitHub. And with this, I just want to open up for questions. So I'll just end my screen sharing and answer any questions you might have.
All right, thank you so much for that great presentation. We have a few questions in the chat, and we'll start with Morten. So if you can get on screen. Sorry, that's this is Morten. So Dependapod seems cool. Would some of that leak into Azure Pipelines rather than having to use the free but rather bad white source Bolt tool, or one of the licensed products like Snyk?
Yeah, I think that is a really good question. So I don't think these features will come to to Azure DevOps. So they're very specific to GitHub. There's also been a lot of work going into sort of integrating it. So originally Dependapod was an acquisition, so it was a separate tool that was built, and so it's not. I don't think it's coming to Azure Pipeline. So it will continue to be a GitHub only feature towards the future.
Okay, and thank you for that question, Morten. The next one, Rune. He asks, is it good practice to include a CVE ID in a commit message when fixing dependency version in a project that has a security issue? I see Dependapod default messages don't include it.
Yeah, I think that's a really good question. I mean, the traceability is there, right, in the pull request context. So that's where you can find a lot of details. And then, of course, also in the security alerts on GitHub. I think it's a really good suggestion, to be honest. I think it depends a little bit on how you manage commit messages. So we see so many different teams, you could say like having different policies or best practices, or sometimes almost religious beliefs in how to work with commit messages. To be honest, yeah, I think it's a really good feedback. I think it would be a really good thing to add, because I think by default, you're right. The default commits of Dependapod do not include that CVE. But if you really rely a lot, so if you use a lot of Git client, for example, so Git client command line, use a lot of Git log and things like that, it might be really useful in order to have that information in the commit rather than in the pull request context.
Thank you, Rune. And we have the next one from Florian. Can Codespaces detect my project type and spin up an environment with required dependencies automatically? E.g., if I use a common package manager like npm, Maven, etc.
I would have to look that up. I haven't been spending a lot of time with Codespaces so far, to be honest. My guess is that there is some work you need to do. There's some configuration you need to initially do to set up your project. So rather than, I think you can spin them up on the fly, but out of the top of my head, I do not know exactly what they will, how intelligent it will be in the sense of like, will it automatically resolve a lot of things based. So typically you would add like a configuration for your project, and then you specify, how your development environment should look like in code spaces.
Well, thank you for that, Florian. We don't see any more questions in the chat. We do have a few from ourselves, me and Oddbjørn, just quick ones to perhaps wrap up until there are some more questions. The one question we had was, do you see any future for GitHub going on-prem?
What do you mean with going on-prem, like providing an on-premise version, or?
Yeah, like an enterprise on-premises version. Do you see that in the future for GitHub?
We've been having that. We had that already since 2012. So there is GitHub.com, GitHub Cloud. Then there is GitHub Server, so you can spin up your own GitHub. And so when customers buy licenses for GitHub through the enterprise agreement, so like a Microsoft enterprise agreement, they get both. So you will just have licenses for the individual users, and then you're free to spin up your own on-premise GitHub environment if you want. So a lot of like customers that have like compliancy and regulatory kind of constraints, especially in Europe, right? Because the GitHub data, so .com data, resides in the US. So especially in the DACH, so in the German countries, we have a lot of customers that are running GitHub Server. So it's been there for a long time. However, we've recently made a lot of changes to it, because with the new features like actions and packages and advanced security, we really had to completely re-architect. So it's now a complete containerized environment, although we still ship it as an appliance. So it's super easy to run. You can run it in a cloud also. So in Azure, for example, there's just a machine ID that you apply and you can spin it up. So it's been around for a long time, and it's still used by a lot of customers that have, that mainly around data locality requirements. So having to store the data in the region.
Well, thanks for that. That was a really good question, Oddbjørn. And I guess one for myself, just to wrap things up. You talked about CodeQL, and it's a really cool feature that you can scan for vulnerabilities in your code base. And I was just wondering, as a package manager myself on GitHub, can I rely on it being as quick as possible to find vulnerabilities when they show up in the CVE database? And will it in the future support any language that I choose? Or do you see a future where it's perhaps more .NET, Java, certain languages only?
Are you more referring, because I think there's two things. I think one is you're mentioning like the advisory database that is more like, that is a database with known vulnerabilities for open source libraries. So you mean to manage your dependencies, having a wider language support, or are you talking about code scanning, just scanning your own code for vulnerabilities?
I guess perhaps it's both. The repository, I guess, is both community-driven and also driven by those who maintain the product. So just curious about the language support there, really, the scanning of the source code. If I bring to a project Go, for example, can I get that feature today, or do you know any plans for supporting lots of different languages?
So I know Go. So CodeQL supports Go today. So for code scanning, it's supported. For dependency management, I'm not 100% sure if Go is a supported language out of the top of my head, to be honest. And then there's also even two sides here. So there is dependency alert. So that is like security dependencies. So, alerting you on vulnerabilities. And then there's also the updates, right? Because there is a wider set of languages that are supported to help you to update. So for example, you can receive updates on Terraform, but we do not really kind of have like, security alerting for Terraform modules, like from a vulnerability database, for example. But you can set it up with Dependabot and say, hey, whenever I consume these Terraform modules that are maintained as open source, for example, and whenever there's updates or new releases available for these modules, just open a PR for me and help me to just keep them up to date.
Sure, sounds good. And just to wrap things up, the final last question is: GitHub on-prem available as a free version that is without a license?
No. So GitHub on-premise, so GitHub server requires GitHub enterprise licenses. So that is a specific plan that you need to have in order to run your own GitHub.
Okay, thank you for that, Ashish. And I think that wraps things up. We're out of time, and just want to take the opportunity to thank you, Bas, for joining us today, and thank you also for those of you at home who are watching the stream today. Thank you so much for watching, and we'll see you soon.
Thanks for having me. Thanks. Goodbye.
Thanks.